Hey everyone, this is Mr. K, and today we're going to go over how to find the area between two curves using integrals. So the first example I'm going to do is going to be with the equations y equals x squared and y equals negative 2x to the fourth power. And so just a general rule of how to find the area between curves is going to be the integral of your top curve, whatever that happens to be, minus the area of your bottom curve, whatever that happens to be. So just in drawing this picture, I'm only going to do part of the area between because I don't need to do the whole thing. So I'm going to do a graph of x squared, which is going to be a parabola, and then this will also be a wider parabola, kind of coming down. And so this top equation here is going to be x squared. The bottom equation is going to be the negative 2x to the fourth. And so if I wanted to find the area between those two curves, I'm looking for this space here and this space here. And we'll say that this is going to be at x equals 1 and x equals negative 1, just to keep it simple. There's a couple different ways you can set this up. To start, first, you don't need to worry about whether the area is above or below the x-axis. I know sometimes that's like the negative area. Again, that's all taken care of already with this when we do our integrals. So the only thing we need to do is just set up, there's two ways you can do this. I personally would say, okay, I know that these equations are even, so these sides are going to be equal areas, so I'm going to split this up into just starting here at x equals 0 and going to 1, and then multiplying that area by 2. You could change it, and I'll show you what that would look like, but I'm going to start with the way that I would set it up first, which would be I would do 2 times the integral from 0 to 1, and now I'm going to write out my top curve, which is going to be x squared, and then I'm going to subtract my bottom curve, which is the negative 2x to the fourth, and then we would do all that with the dx there to keep our notation proper. So then from here, it's just do the integration and substitute in your upper lower bound, and so I would have using the power rule, I would have x to the third over 3, and then since it's subtracting a negative value, I'm just going to make it plus positive, so it'd be plus 2x to the fifth over 5, and then we'll be substituting in a 1 and a 0. Now substituting in a 0 isn't going to, it's just going to come out to be 0, because we'd have 0 cubed over 3, 0 to the fifth times 2 over 5 is still just going to be 0. So really then all you need to do from here is substitute in a 1, and so you'd have 1/3 plus 2/5. And then if you go through, type into the calculator, I guess I can do that. We would have, you can see up at the top here, I would do 2 times 1/3 plus 2/5, and then I would again convert that to a fraction, and you get 22/5. Can't really see, it's not really focusing on me. See? So hopefully you can kind of make that out, but if not, try it for yourself. You should get 22/15 for your answer. And then the other way you could do this, and again, I'm just going to set this up, I won't go through the whole process here, but you would do the integral from negative 1 to 1, because that would be like where our area starts and then where our area ends. And then it's still doing the top curve, which is x squared, and then minus the bottom curve, which is negative 2x to the fourth. And again, if you go through, find that integral, you should still end up with the same value of 22/5. Let's see if we can get this to focus a little better. There. Another situation that can occur is you can have where the equations are kind of like flipped, where it's going to be x equals. So we could have the equations like x equals 12y squared minus 12y cubed, and then x equals 2y squared minus 2y. And so if you have a situation like that, first, again, drawing a sketch will be helpful. One of the graphs kind of comes in like this, and then another one like this. And so the area between the curves would be here. So you might be wondering, well, how do we do this if it's y and not x? First, let's figure out which curve is which. This one here is the 12y squared minus 12y cubed. And then this equation here is going to be the 2y squared minus 2y. And so a really easy way to do this is to just turn your paper. Because now x is positive over here, negative down here, and so your x and y axis just kind of flip, but you still end up doing the same thing. So I would still, if you find this intersection, this is at when y equals 1, and then this intersection here is at 0. So I would integrate from 0 to 1, and I would still do my top curve, which is 12y squared minus 12y cubed, and then I'd subtract the bottom curve, which is going to be that 2y squared minus 2y dy, and then it's the same thing that we did before where you do your power rule. Again, substituting in 0 won't change anything, so you substitute it in 1 and get your answer. And then the last situation that can occur is, what if the graphs change when which one's on the top, which one's on the bottom? So my example that I have for that would be y equals negative x squared plus 3x, and y equals 2x cubed minus x squared minus 5x. And so what that looks like, if we were again to sketch a graph of that, we're going to have our cubic graph, and then we're going to have a parabola that comes up. Again, not a perfect picture, but this would be the space that we'd be looking at, is that area right there and this area right here. And so this top equation's the 2x cubed minus x squared minus 5x, and then this equation here is going to be the negative x squared plus 3x. So the way that you would approach this is just separate it out into two separate integrals. So this intersection point down here is at -2, -10, and then we have 0, 0, and then this point out here is actually at 2, 2. Again, my picture's not super accurate, but you kind of get the idea. So the first integral, our top curve is the 2x cubed minus x squared minus 5x, and we want that from -2 to 0. So I would set this up with my first integral of from -2 to 0 of that top curve, which is 2x cubed minus x squared minus 5x. I would subtract my bottom curve, which is negative x squared plus 3x, and then just be careful. I personally would distribute this negative sign or subtraction sign. I would combine like terms if possible, and then I would integrate. And then you're going to want to add to that. Now, because our top curve changed, we're going to have to flip our top and bottom curve for our integrals. So now we want to integrate from 0 to 2 of, and now that first curve is negative x squared plus 3x, and then we'd subtract, and again the parentheses are important here, the 2x cubed minus x squared minus 5x. And then it's just a matter of going through and completing that integral. Again, this is the x squared minus 3x. This is that 2x cubed minus x squared minus 5x. If it's a little smushed on the end there. But then just combine like terms, do your power rule, substitute in your numbers, and you're good to go. So I hope you found this video helpful, and I will see you in the next one.